Hi, this is Chris from Flux Films, and today we are looking at the Tesla Coil, a very awesome device, this one based off of a Slayer exciter circuit, which I will teach more about later. But basically what it does, it oscillates really fast and causes a high voltage to build up in this transformer right here, which then can illuminate this bulb wirelessly. So if we can have the lights shut off, I'll turn on the coil and you will see, if I bring this bulb within the vicinity of the device, you will see it illuminated. And if I now actually touch this to this, you will see arcing and sparking and all sorts of awesomeness. Hello, this is Chris again, and right now I'm going to be explaining the circuit diagram for the Tesla Coil. So first off, you see there's a battery, and this is to supply power for the circuit. This is a resistor. This is a transistor, an LED, and of course the small coil and the large coil you see in the Tesla Coil. This sort of dotted line right here isn't a real component of the circuit, but it's representing the parasitic capacitance between the top of the coil and ground. So first off, the way the circuit actually operates is when you first turn on the battery, current flows through the circuit, through here, through this coil, down through the transistor, and back to the battery. The reason for this is that a transistor is like a switch. So when you apply a voltage to the base, it allows current to flow through it. And in this case, voltage being applied to the base through this biasing resistor right here. Once this occurs, it causes a magnetic field to be generated in the vicinity of the primary coil, which induces a large voltage in the secondary coil that you see. And at the bottom of the coil, that voltage is negative. So that negative voltage is then attached to the base of the transistor via this cable, and it does two things. Since it's negative, it shuts off the transistor because you need a positive voltage. And the other thing it does is it illuminates this LED referenced to this part of the circuit. And once that happens, you end up with a flash of the LED, and the circuit turns itself off. And then, of course, the process starts all over again. And this cycle, this oscillation, happens at a very high frequency, high enough to where you can actually generate a high voltage in this secondary coil due to it acting like a transformer, because a transformer is essentially when you have a large number of coils in the secondary and a small number in the primary, you get a high voltage on the output. And since that just keeps happening continuously at a really high rate of speed, the LED turns on and it looks like it's solidly on because you can't see how quickly it's flashing, and it induces a very high voltage field in the vicinity of this secondary coil. And that is what allows you to hold, for example, a light bulb near it, and it will illuminate because of the extremely high frequency, high voltage field. As you can see, the light is illuminated, but if I bring this metal close to this cable, you will see it sparks and arcs. And the same thing can even be observed with my finger, though that is a little bit more dangerous.